Well, here we are. We're looking at some more examples of integrating some trig functions, and what we've got here this time is an even power. And as I noted before, if I just scroll back up, that if neither is odd, we use a different method, and that's essentially what we're going to do now. Use a different method to integrate when we have this even power. Now, there's not necessarily only one way to do these sorts of problems. You may do it one way, another person may do it another, and your results may end up looking quite different. But if it's legitimate and it works, okay, those functions still are the same. Okay, as we know that when we graph trig functions, sometimes a cos function, sometimes it's a sine function, and just because they are essentially the same graph but shifted but out of phase of one another, you can get different results but yielding the same graph. So it's a similar situation with these. So let's look at this one. How do we go about doing it? If we have a look on here, okay, on our specialised information sheet, there's no particular result on here that matches with sine squared x except this one here, the 1 minus cos squared x, but that's not going to help us in this particular case. So what we're going to do is have a look at the methods information sheet, because on there we have one that we can use. And if we have a look at that, we can see that cos 2a is equal to cos squared a minus sine squared a, or cos 2a is equal to 2 cos squared a minus 1, or, and this is the one we'll use, cos 2a is equal to 1 minus 2 sine squared a. And if we just turn this around a little bit, we can say that 2 sine squared a is equal to 1 minus cos 2a, and therefore sine squared a is equal to 1/2 minus 1/2 cos 2a. Okay, and so we can apply that in this case. So sine 2x, okay, we can write as 1/2 minus 1/2 cos 2x dx. Now, we probably don't want these halves here, and so we can easily take that out to the front. So we'll have 1/2 out the front, and then it's 1 minus cos 2x. And then we can integrate these separate functions here nicely. Okay, so that just gives us x, and this will be negative minus 1/2 sine 2x, and plus a constant of integration. Okay, and go from there. Clearly we can make that 1/2x minus 1/4 sine 2x plus c. Let's look at another one. Okay, this time integral of sine 4x. Okay, and again we need to use another method, and so we're going to utilize some of these formulas which we've been given. Okay, so from this above here, okay, we know that sine squared a is equal to 1/2, we might just put that out the front straight away, minus cos 2a. but we want a pair of 4, so let's square both sides. Okay, so this becomes sine power of 4a equals, well, that's going to become 1/4 because we're squaring the 1/2. 1 minus cos 2a all squared. And so we're going to utilise that. So let's substitute that in place. So instead of having sine to the power of 4x, we'll have 1/4 times 1 minus cos 2a all squared dx. Okay, what we can do here now is square that. We'll take the 1/4 out the front, and this becomes 1 minus, expanding this binomial product, we have 2 cos 2a. We shouldn't have a, we should have x, shouldn't we? And plus cos squared 2x dx. Now it doesn't look like we're simplifying things at the moment, does it? But what we've got here, we need to now eliminate this cos squared 2x. So we're going to utilise this formula, okay? Cos 2a equals 2 cos squared a minus 1. Okay, so cos 2a equals 2 cos squared a minus 1. We'll rearrange that, so we have 2 cos squared a equals cos 2a plus 1, and dividing by 2, so that cos squared a equals 1/2 at the front cos 2a plus 1. So if we apply that to what we've got here, cos squared 2x, then we've got cos squared 2x will be equal to 1/2 times cos 4x, okay, because the angle is doubled, we have to double that, 4x plus 1. And that is what we can replace here. So 1/4 at the front, 1 minus 2 cos 2x plus 1/2 cos 4x plus 1. Now just watch me closely as I go through these. We'll put the 1/4 out the front, and we'll just split this integral. Okay, so just splitting this integral into 2 parts, and we can go from there. Okay, so to integrate that, that becomes x. This one will become minus sine 2x, and then over here we've got a 1/2, and then 1/4 sine 4x plus x. and now we'll multiply throughout. So we have x over 4 minus 1/4 sine 2x plus, well, that's 1/8 times another 4, so that's 1 over 32 sine 4x plus, well, it's a half times that times 4th x over 8 plus c. Okay, so we can still collect some like terms, just these ones here. Three eighths x minus 1/4 sine 2x plus 1 over 32 sine 4x plus c. Okay, so a bit more of a longer one, that one. Okay, but if we just have a look at the steps involved, we first need to change this power of 4, and we do that by using our sine squared a and then squaring both sides. Okay, expanding our binomial product, and then we've reduced the power essentially by 2. Okay, and then we can redo that same thing. Okay, so using the double angle formula, substituting in, and then once we have no powers, okay, we can integrate. Okay, because we can't really do it when we have even powers. We need to make changes to whatever's in the integrand. Okay, so we'll work through another problem now, but in the next video.